What we're going to be talking about today in geometry in lesson 69 is properties of trapezoids and kites. And I really feel like a lot of this information you'll already know, at least some of it, okay? Some of it's very similar to stuff that we've covered with triangles. We should already know some things about trapezoids because at least what we're going to be covering here. If you remember the lesson we covered on isosceles triangles, okay? We're going to hit some things with isosceles trapezoids. It's going to be very, very similar to that. What we want to understand first as we talk about these is the base of a trapezoid. Okay, the bases of the trapezoid, because we've already been working on finding the area of trapezoids, right? How many of you remember what the formula for the area of a trapezoid is? Anybody remember? It's not base. It's base 1 plus base 2 times the height divided by 2, right? So we should already be able to identify the bases, correct? And I've got them labeled here. I don't label, the top one base 1 or base 2 because it doesn't really matter, right? Because we're just adding. Addition is commutative. So we understand already that the bases are the parallel sides, all right? And so that makes the other two sides, we call the other two sides legs. And just like in a trapezoid, in an isosceles triangle where we have our congruent sides, we also have base angles, all right? And our base angles are in these 4 places, but they go together, all right? So you'll see that these 2 red lines coming to these 2 base angles, all right? Those are base angles to each other. You follow me? Okay? And the top 2 are base angles to each other. All right? Let's see, and because we see some of the things here, base angle of a trapezoid, which is one of a pair of consecutive sides, whose common side is a base of the trapezoid. Okay, so we have our base angles. All right, base of a trapezoid is its 2 parallel sides. So from here, let's go on to our next set of notes. Okay, the legs of a trapezoid. We've already labeled in the last page that our base sides, our legs are these 2 non-parallel sides. Okay, but just so we see it independently on this side. Now, we've talked about mid-segments of triangles. Now we're going to talk about a mid-segment of a trapezoid, and it follows the exact same set of rules. It is the segment whose endpoints are halfway, or are half the distance of either side. So you'll see these tick marks over here, which means this point is half the distance of that leg. Okay? This point over here is half the distance of that leg, right? And when we connect those 2 endpoints, we wind up with something that is the mid-segment of the trapezoid. The segment whose endpoints are the midpoints of the legs of the trapezoid. So this line right here. And it will be parallel to the 2 parallel sides. All right, which brings us to some of our postulates and theorems. Our first one is theorem 69-1. I know that it's up there and you can read it, but Aaron, would you read that out for us?
It says that a trapezoid is parallel to both bases and has a length that is equal to half the sum of the bases.
Okay, so my red line here is equal to half the sum of the 2 bases. So QR plus TS divided by 2 is going to be equal to UV. Okay? So it's half the length when you average them. So it's the average of the 2 lengths. So if I knew that QR was 4 and I knew that TS was 8, what would I do with 4 and 8? Adam, what's 4 plus 8? And then what do I do with 12? Divided by 2, so what is UV? 6. Okay? Now, we will get into more complex questions like, let's say that I know that UV is 6. Could I find TS? Okay? How would I do that? Let's give that a letter designation. Let's say I don't know what TS is. I know 4 plus X, okay, equals 6. So then I would multiply by 2 on both sides, correct? So I would get 4 plus X equals 12. Then what? Divide by 4? No. subtract 4. What's 12 minus 4? 12 minus 4? 8. Okay? So we see that we get that 8 that we started with, right? Okay, this is just like our midpoint formula, where I knew what the midpoint was and I knew what one of the coordinates was, but I didn't know what the other coordinate on the other end was. We solved this exactly the same way, except I don't have to do it twice where I do it with x and then do it with y. Okay, so you guys have done this math before. All right, our next one is an isosceles trapezoid. So the same rules pretty much apply to this as apply to an isosceles triangle, but we're doing it with an isosceles trapezoid. It has congruent legs. So HK is equal to IJ. All right? And so that means that they have congruent base angles. Okay, which means angle K is congruent to angle J, angle H is congruent to angle I. Okay? And because we're dealing with quadrilaterals, K plus H equals 180 degrees. Okay. All right. Base angles of an isosceles trapezoid are congruent. So you've got those pictures there, and you can put those in your notes. The other property, we only have two specific properties to isosceles trapezoids. The other one is that the diagonals of an isosceles trapezoid are congruent, which means that SU is congruent to TV. Okay? Those two things are congruent. All right. And then finally we get into kites. Kite is probably the most forgotten of our special quadrilaterals. Right? If we talk about quadrilaterals and I ask you what different types of ones do we have, you know, under parallelograms we have rectangles, rhombuses, and squares. Outside of that, we have trapezoids and kites. So trapezoids and kites are quadrilaterals that are not parallelograms, but are special in their own rights. Okay? The diagonals of a kite are perpendicular. So you see that GE is perpendicular to FH. And so all of these angles around here are going to be right angles, which means all of these triangles. Okay, a kite is made up of 4 right triangles, not unlike a rhombus. Okay, but you'll notice that it's different in that it's not a parallelogram because opposite sides are not congruent, opposite sides are not parallel. All right, I believe that is the last of our special information. So from here, we're going to get into some of our information. Okay, these questions here. All right, I want to say that we've got, let's see, we've got about 9 questions. We'll cover as much as we can. In trapezoid, MNOP, legs MP and NO are congruent. If angle M is 128 degrees, find angle N. Can I just do this off the top of my head? Maybe you can if you're like Goodwill Hunting and you can visualize the whole thing, right? But what do we probably need to do here? Draw it, okay? So I'm going to draw a trapezoid. All right. It says the angle M is 128 degrees, so I'm going to make that one of these obtuse angles. And then what would I make this upper right angle here? What would that be? What's that? B? P? No. Well, I mean, I guess you could. You would have to make that N, though, right? O and P. So one of our rules whenever we're labeling, just to kind of go back and reiterate, is we want to go in order as we go around, correct? Okay. So it says that MP and NO are congruent. Okay, well that doesn't really work in this picture, does it? Segments MP and NO, do those look congruent to us? Okay. So I'm going to change this at least so that it bears some resemblance to this. So I'm going to go the other way around and see if it, let's see, MNOP. Does MP and NO look congruent now? Could they be? Okay. So I'm going to put my tick marks here and here. I'm going to put 128 degrees there. Those 2 tick marks make this trapezoid what? What is this trapezoid now? Specifically, what type of trapezoid is it? Go back and look at the notes if you need to. I will wait. It's an isosceles trapezoid. Very good. All right. So I should know a couple of things about isosceles trapezoids. What do I know? I should know two things about isosceles trapezoids. Name me the first thing you know about isosceles trapezoids from your notes. Base angles are congruent. All right. So what does that mean about angle in? Is congruent to angle O? No, because in and O are not base angles to each other. Okay, what is in a base angle with? Angle what? What? M. Okay, because they are on the same base. These two are base angles to each other. And you're right saying base angles are congruent, but base angles to each other are congruent. Angle P and angle O are bases together. Okay? So what do we know about angle in then? What does it equal? It's the same as M, and M equals 128. So in is 128 degrees. So what we need to be able to do with a question like this is be able to draw it accurately. Okay? And you notice that just by labeling it the other way, we get something that doesn't work. So if it doesn't work, then we need to go back and redraw it. All right, does that make sense? So we get 128 degrees B on that. Okay? All right, number 2, we have what is the shape of this? It's a kite. What do I know about kites? I only have one rule for kites. Their diagonals are perpendicular. Okay, find the length of YZ. That right there. Okay, how can I do that? Pythagorean theorem. So help me fill that in. Okay, what's 12 squared? 144. Okay, 144 plus 36. And you're saying that 144 plus 36 is 180. Okay, what do I need to do with 180? Square root, and because it says to the nearest tenth, can I just plug that in my calculator? Okay, what's the square root of 180? 13.4. All right, feel pretty good about that one? We can do these. Okay. All right, let's come down to number 3. Rectangular pyramid. Now let me look at this. We're going to skip 3. 3, I don't know how this got in here, but this is actually a lesson 70 question. So we'll look at that with our next lesson. We won't look at it today. Let's make sure I don't have any of those others. Lesson 40 is a lesson 70. We won't do that one today. Question number 5. Question number 5. And this one, for whatever reason, okay, didn't finish out there. Okay. This may be like one of the toughest questions that we see. Okay, so be ready for this. All right, the perimeter of isosceles trapezoid is 55.9, which means this. Okay, it means that side 1 plus side 2 plus side 3 plus side 4 equals 55.9. Do we get that? Okay. They tell me that AB is the mid-segment of WXYZ, and that XY, this top line up here, is 3 times the length. Let me fill in some things that are missing. This is Z and this is W. Okay, that, let's see, let me go back to this. That XY, this line up here, so you can see it whenever we're talking about it, is 3 times the length of ZY. Okay, let's see, this line right here. Okay, we want to find the length of all 4 sides. Okay, so I'm going to start off by referring to this as X, which means this is 3x, correct? All right, we'd get that. And because it's an isosceles trapezoid, I know that xw is also x, correct? Because they told me that it's isosceles, so my legs are congruent to each other. They don't tell me anything about zw, though, right? Okay, so in terms of perimeter, I know this. I know 3x plus x plus x plus an unknown plus zw equals 55.9. Okay, that's as far as I can go with that, correct? All right, and if I also refer to this as, let's call this A, let's call this B, all right, I do know this. I know that A plus B divided by 2 equals 19.35. Okay, do we understand that? Because we're talking about mid-segment. Okay, AB is the mid-segment of XY plus ZW divided by 2. Okay? All right, so what I can do from here is I can at least find out what A plus B equals, so I can multiply by 2. So A plus B equals...
Pardon the interruption. The following students need to report to the high school office at this time. They also need to make sure that they bring their Chromebooks and their earbuds. I need Samuel Kulo, Abby Sarabia.
All right, now somebody with a calculator, take 19.35 and multiply it by 2 and tell me what you get. $38.7. Okay, so far, that makes sense. Now, what I want to do is I want to take that perimeter and I want to subtract 38.7 because xy plus zw equals 38.7, right? So let's subtract that from the total perimeter. So 55.9 minus 38.7. You're going to understand why this is maybe one of the most difficult questions to do. Okay, what is left? 17.2. Okay, 17.2. All right, which means that that's what's left after I took A and B out, correct? Yes, which means YZ plus XW equals 17.2. And because those two lengths are the same length, we can take 17.2 and divide it by 2. What is it? 8.6, which means this equals 8.6 and this equals 8.6. Do you follow me? Now, what did we say that XY was? We said it was 3 times the length of XZ. So if I want to find XY, what do I need to do with 8.6? Multiply by 3. So 8.6 times 3 equals what? 25.8. So now I know that this is 25.8. We know that this is 8.6, this is 8.6, so can I find B? How do I find B? We have 2 options, the easy way and the hard way. The easy way is to add up 8.6 to 8.6, which we know is 17.2, right? And add that to 25.8 and subtract that from the total perimeter. If you want to go the harder way, you could go the midpoint way and say 25.8 plus x divided by 2 is 19.35 times 2 on both sides, subtract 25.8 from that and get there. I would rather go the perimeter route, right? What is 17.2 plus 25.8? What is it? 43? Okay, and then we're simply going to take 55.9 minus 43. What do I get? 12.9. Okay, and you could check that. Okay, 25.8, 8.6, 8.6, and 12.9. Okay, that should be B right there. I'm not promising that this won't be on a test. It might show up on a test. If I see it, I might take it off, but do you have all the work? Okay, I'm telling you that if it shows up on the test, it will be this exact question with this exact answer, but you won't get credit for it unless you can prove the work. Okay? So that is that. I'll make sure it's probably one of the latter questions that you do. 6, we're back to our kite PQRS. They tell me the angle QPO. Start with Q, go to P, come over to O. So what I'm seeing right here is 50 degrees. And Q, let's see, they're saying QRO is 70 degrees. Okay, find the measure of angle PQR. Okay, we want to find that angle right there. Well, how do I do that? Should be pretty easy, right? Anybody see that this is a whole triangle where I know one angle is 50 and one angle is 70? What do I do here? All right, 180 minus 70 plus 50. 70 and 50 is 120. What happens when I subtract 120 from 180? I get a remaining 60 degrees. Okay, 60 degrees. There's a couple other ways to do that, but I think that's the most direct way of looking at it. You could split that into 2 separate right triangles and solve that way, but it takes a little bit more time. It's not really necessary. Okay, 7, another kite. Heath is making a kite. He needs to cut 2 wooden rods, one that goes from B to D, and the other one that goes from A to C. We want to find the total length of the wooden rods Heath needs. So we actually want to find these lengths and we want to add them together. Okay? One of the things that's going to happen in a kite is that AC is bisected by BD. So what do I know this length to be right here? 4 inches. Okay? Because it's BD is a perpendicular bisector. All right, so what I need to find is this length. And I can find that length by finding this guy and that guy, okay, using the Pythagorean theorem. Notice that this length is 4 and this length is 5. Can anybody tell me what that length would be? 3, because it is a Pythagorean triple. But I could also use the Pythagorean theorem by taking 4 squared plus b squared equals c squared, right? So just so that you're familiar, 4 squared plus b squared equals 5 squared. We have 16 plus b squared equals 25. What's 25 minus 16? 9. What's the square root of 9? Is it 3? All right, so I know this length is 3, okay, and I need to find this length now. And I can do that by using that same 4, and this is 10. So I can do 4 squared plus b squared equals 10 squared. 16 plus b squared equals 100. B squared equals, what's 100 minus 16? What is it? 84. Okay. Okay, we'll square root that. So we'll get b equals, and it wanted this, find a total length. I get something like 2 radical 21, but you can get a different number for that. What do you get whenever you plug that in your calculator? 9.16. All right, and what's the total length? So this is 9.16. So what's 4 and 4? 8 plus 3 plus 9.16. What do you get when you add all of that together? 20 point what? Which rounds up to 20.2. Okay? When we do that, we want to think about it in terms of right triangles and solving lengths and adding them together. A lot of folks will forget to add all of them together at the end, though. So make sure that you pay close attention to what it's asking. All right, 8 and 9 come back to some trapezoids. Here's an isosceles. Notice that it's diagonals. What do I know about the diagonals of a trapezoid, of an isosceles trapezoid? They're congruent. So if AE, that's this length here, is 13.3, and DE is 7.3, and I know that doesn't look right because it's got the blue line being longer than the red line, but in any case, find the length in feet of AE. Wait. Oh, if BD, I'm sorry, I got that. I'm going to have to start over here. I got all that wrong. Okay. If BD is 13.3 and DE is 7.3. Okay, we want to know just what AE is, just this short length right here. What do I do? 13.3, Brady said 13.3 minus what? 7.3, because we're going to take that whole length minus the long length. That's going to be leaving us with the short length, and the short length on both of them should be the same. 13.3 minus 7.3 is what? Or 6.0 feet. Okay, do all of us understand how to do that and why we did that? Okay. Final question. Number 9. Mid-segment of trapezoid QRST is shown below. I'll find the length of UV in feet. All right, this is one that I want you guys to do on your own, and as soon as I have your answer, I'll let you get started on the homework. I'm going to stop the video right here.